the odds solutions. Okay, let's check out these here. These are the ones that we're going to start with the ones that you did for homework. So that's number 3. So number 3 is the lifespan of the battery is the amount of time the battery will last. The distribution of the lifespan of a certain type of battery is normal. Lifespan normal. And it has a mean of 2.5, standard deviation of 0.25. So which of the following is closest to the battery with at most 2.1 hours? So this is what you have. You've got normal model, mean of 2.5, derivation of 0.25. And it says, oops, this 2.5, 2.1, and this is what it's looking for. So this here you can see shows you the solution as far as using z-score, but you would use normal CDF, where this is the lower bound is negative infinity, upper bound is 2.1, mean is 2.5, and standard deviation is 0.25. Normal CDF, of course, is on our distributions menu. Okay, let's look at number 3. Let's look at number 7. It says of the following dot plots, which one best presents the simulation described? I'm looking for 1.5% of flights canceled by major airlines, and I want a simulation with 50 trials. Estimate the number of canceled flights for random sample of size 100. And where the probability is the canceled flight is 0.015, because that's 1.5%. Okay, so let's go ahead and look at this. Let's look at this one. This one's basically uniformed, right? Where each one has the same probability. So let's see what's going on here. If I have a 0.015% chance, then this is telling me that each canceled flight, so 0.015% times 50 is going to be 0.75. And so what that means is this is saying I have 50 trials to design the estimate number of canceled flights from a random sample of 100. So I have 50 different trials, random sample of 100. So each dot represents n is equal to 100. And I have 50 dots. So that's what's going on. And the probability of success, a canceled flight, we're calling it success, is 0.015. Okay, so we're going to, most of the time, if I go here, 0.015, right? That's times 50, I'm going to get 0.75. So since this is binomial NP, right? Because I have a set number a set number of trials. N is my number of trials, and that's N, and P is the probability of, and so it's going to be, most of them are going to be about 0.75. So as I said, this one's uniform, that's straight across. This one here, you can see is they're right near 0.75, about 1, which that's why that's good. This one, most of them are over here, so we know that's bad. Most over here, so that's bad. And this one is most over here, so that's bad. So you can see this one says the simulation's 50 trials, and so of size of 100s, you're going to be about 1.5. Oh yeah, because the sample size is 100. Sorry, I did mess that up because I did 0.75. I did sample size of 50. I don't know why I did that. So that's 100, which is going to be 1.5. So that's why this here is where the center is. Okay, let's go to number 9. Okay, this is 9 here. And this is an online news report. Proportion of smartphone owners whose certain operating system is 0.216. 2 simulations are conducted to create a sampling distribution of a sample proportion from a population with a proportion of 0.216. Simulation A will consist of 1,000 trials, sample size of 50, and simulation B will be 500 trials with sample size of 100. Okay, so which of the following describes the center and variability that should be apparent in the distributions of A and B? Okay, so remember, my center of my mean is always equal to my mean. And so my variabilities, remember, is always going to be bigger, because remember the variability, this is going to be this over square root of n, okay? So the centers are going to be the same, so that's equal, this says equal, this says equal, so it's not these. And the variability of A, let's see which one's going to be bigger, because you have A is 1,000 trials of a sample size of 50, and B is 500 trials with a sample size of 100. And so you have, as you can see, the standard deviation of simulation of A is going to be greater than B, because the sample size of A is smaller than B. So that's what you're trying to look for, is that it doesn't matter how many trials you have, because each dot is how many trials, but the size is what I'm looking for. So you don't need to have the trials, you need to look at N. So NA is equal to 50, and NB is equal to 100. So remember, I'm dividing by the square root of N, so when I divide by the bigger number, it's going to be a smaller. So this divided by a bigger number make it smaller, so that's why B is true. Okay, let's go to number 13. Oops, sorry. Okay, 13, it says, which of the following must be true? This is the main thing. Must be true for an estimate of the population parameter to be unbiased. Remember, to be must be true, the expected value is the estimate equal. That's exactly what we just talked about. That this is going to be equal to this. Or remember, we did this. So that's just saying that the estimator has to be the same. Okay, and that's just the definition. Number 15, you guys have to do in your work here. So now let's go ahead and look at B. So we're going to start with 3 here. So I'm just doing the homework ones first. All right, so 3 says a sample of the manufactured items will be selected in a large population where 8% of the items are defective. The following, which is the least value for the sample size that will be allowed for sampling distribution sample proportion to be approximately normal. Okay, so you have, let's see, it tells you we need NP, 0.08, because this, we're going to say it's in order to be approximately normal, remember we have to have NP has to be greater than or equal to 10, and N1 minus P, so which is 0.92, has to be greater than or equal to 10. This is the only way that I can have this be normal. So I have, if I just do a little bit of math problem, I see that 10 divided by 0.08, so N is greater than or equal to 10 divided by 0.08, and that's 125. And so 10 divided by 0.92 is equal to 11. For this to happen, well, if I use 11, that won't be true over here, so I have to use 125. So you see 11's there, but that's only going to be good for this one. So I have to use the bigger one, because if I use 11, then that's definitely not going to work for this problem, because it's not going to be bigger than 10. So that's why I have to use 125. Okay, let's jump to 7. All right, so this is wanting standard deviation. So for standard deviation, you guys just need to see what type this is. It tells you it's 2 proportion. If you look at your formula chart is going to be P1 minus P over N1 plus P1, these are all 1s, P2, 1 minus P2 over N2. This is on your formula chart under the standard deviation. And this is what a 2 population is going to be. So if you look at it and see this one has 50 and this has 100, looking through them, obviously that's definitely wrong. That one's definitely wrong. This one looks similar to this one. So, and this one is not right, because see, it's P up. This is P hat. I just saw that. So this is not right and this is not right. So I didn't even have to read the question, and I knew this had to be it, just because based on the formula themselves. And remember, this is on your formula chart, so look on the back and find it on your formula chart for the 2 sample T. Okay, so let's go to 11 if there's an 11. Yes. Okay, so this one, which is the following best interpretation for the standard deviation of this is equal to 0.015. So let's just look at the answer, and then we'll look at see why it's correct. For all random samples of 100 garden seedlings and 100, so that's the same sample size, H seedlings, because that's, you see this, that's the sample size. So it's the same sample size. The average distance of all possible differences between the sample portions. The average distance is this. So it's saying, we're just trying to say standard deviation is the average distance from the mean, and so that's what it's saying, is approximately 0.051. All right, so let me show you what's wrong with the other ones. This one says for each sample, that means every single sample, that this would work. And so that's not right. This one says, for each sample, again, not right. This says randomly selected garden setting C and garden setting here. So this doesn't tell me the sample size. So that's why that's not right, because it only works with the same sample size. So this is for all random samples of 100, garden C and 100, 8. So it starts off, okay, the mean of all possible differences is this. Okay, so this is telling you it's the mean. However, this is standard deviation. And standard deviation is the average distance from the mean. So it's just the definition. Okay, so let's go on to the next unit, which we're going to start again on 3, because that's what you had to do for your homework. Okay, the distribution of the number of siblings for students at a large high school is skewed to the right. Okay, with a mean of 1.8 and standard deviation of 0.7. A random sample of 100 students of the high school would be selected with the mean number, and siblings will be calculated. Which of the following describes the sampling distribution? So the sampling distribution is going to be 0.7 over square root of 100, which is going to be 0.7 over 10, which is going to be 0.07. But the mean is going to be still 1.8. So we have, it says, which of the following describes the sampling distribution for the sample mean and a sample size of 100? So I have, okay, so this is skewed to the right. Oh, yeah. Because the size, sorry. I just had to read this. The size is 100, and that's greater than 30. So we know immediately that means it's an approximately normal. Remember, because of the central limit theorem. So we know all those are not right. So these are not right. Approximately normal, that's good. Standard deviation, this says a 0.7, which we know that's not right. We know that it's going to be smaller than 0.7 because we're divided by square root of n. And this one just says less than 0.7. It doesn't tell me what it is, but it is less than 0.7, and it actually calculates it right here for you. Okay, let's jump to number 7. All right, this is what is the mean of the sampling distribution, the difference of means here. And so just with the mean, all you have to do is 2.7 minus 4.2, and that's it. Then that's it. So x1 minus x2, and just it tells you x1 is average spinning time for 3 spinners, and x2 is average spinning time for 7 spinners. So that's it. Okay, 11. Okay, it gives you the sample size. It gives you X bar and gives you S. And it says, Riley, a child psychologist, claims that for all samples of size 40 from the population of infant boys and all samples of size 40 of newborn girls, the mean of the difference of sampling means boys minus girls is 2.2. Is that correct? So it's saying the mean. Well, it tells you here the mean here is 8, because it's saying the mean of all sampling. This here of, okay, that's the thing, is the mean of all sampling distributions. So this is just right here. It says 2 independent random samples were taken, and the time for each were taken of their first words recorded in the summary. This is just 2 random samples that they got. Because this here, the reason that answer C is correct is because this refers to my mean, and my mean in my sample was 8. And so in order for it to be biased, remember the mean of X bar is going to equal the mean. So it's going to be 8. Because that's what we're assuming. Remember, we're assuming what is true. For my, as remember, ho is going to be mean 1 minus mean 2 is equal to 0. And so that would make it 8 minus 8 is going to equal to 0. So because the mean of all differences in the sample means of all the samples of size 40 from the population of infant boys and all the samples of size 40 of infant girls is equal to the difference of populations. So that's why this is going to be C, because this is the part of the sampling distribution. This is just a sample. This is just one sample that was taken for boys and one for girls, but not the actual sampling distribution. Okay, and then that's it for the odds that you had to do for homework. So let's scroll back and have you do the ones that I wanted you to do in class, and let's look at number 1. All right, which is the middle 80% of the heights? So you can do this because it gives you the mean of 70 and the standard deviation of 4. So what I would do is the middle 80%, let me just draw it. It's going to be here. This is 80%. That means that's 10%. That's 10%. All right, and so I don't know this value. So I'm going to put y1, and I don't know, let's just say y2. I don't know that value. But I do know this is a normal model, and the mean is 70, and the standard deviation is 4. So what I would suggest is let's define y1 to go ahead and use inverse norm, because I know that's 10%. So I'm going to say inverse norm, where area is 0.1, the mean is 70, and the standard deviation is 4. So just in your calculator, inverse norm, and that's going to get you 64.87. Now you can do the same thing of inverse norm and now do 10 plus 80 is 90%, and do 90%, 70, and 4, and you're going to get the 75.13. That's one way you could do it. There's other ways, but this is one way. All right, let's look at number 5. Okay, so for this one here, we want to see if it's a normal model. And so it made this here. It says we have the chart. We have A, B, C, D, E, number of observations falling in each interval. Which of the following list counts for A, B, C, D, E respectively is best indicator that the variable can be modeled with a normal approximation. All right, so honestly, I think for this one, we can kind of put it together and say, well, we can try it. So if I tried this one, actually, I'm going to show you the one that's the correct answer first, and let's show you how it works. 10, 2. So if we add them all up, obviously we get 75. So let's go ahead and see how much this is. This, remember, is going to be 68%, 95%, and 99.7%, right? So let's start with this here. So what's going to be on the tail is, or let's go ahead and do here, this. Let's see 51 out of 75. 51 divided by 75 is equal to 68% exactly. They actually got it perfect. Then let's do this one here. So now 51 plus 10 plus 10 divided by 70, which is 71 divided by 75, is exactly, so this is going to be 71 over 75, and that's 95%. And then finally, you're going to have all of them is going to be 75 out of 75, and that's about that's 100%, which is really close to the 68, 95, 99.7%. So I showed you one that worked, but you could do it also. This was kind of a weird one because you kind of had to check it until you found one. Well, I guess actually you could use equations on here too, but I think it's probably easier just to do it the way I did it. So you can kind of look at it really fast and kind of see this is 1, 31, 11, 31. and 1. So clearly you can see that this here is the bulk because that's 68%. You know that's going to be 68%, right? And you know this is going to be 95%. So what's that going to be? 95 minus 68 divided by 2 is going to be 13.5% here, right? That's 13.5% here. So clearly, you know that this number here is going to have to be bigger than this number here, and it's not, so you know that's not going to work. So you can kind of do that already with these because you can see 68%. And then obviously these here at the tail end is going to be the 99.7%, right? So these are 99.7. And so if I just subtract 99.7% minus 95%, because that's, and I have 4.7% left divided by 2. I have 2.35 over here. I have 2.35 over here. All right. So what's that going to do is that's going to tell me, obviously my smallest one's going to be here. So I would have to choose one that has the small, it would have to be kind of like this. It would be small, medium, large, medium, and then small. So this one definitely takes that. This is small, medium, large, and then boom, it keeps going big, so that wouldn't work. This is starts out big, so that doesn't work. And these are all the same, so that doesn't work. So this is the only one that starts out small, then medium, and that's the same size there, medium, small, small, and then large here. So that's the only one that works. All right, number 9. Oh, wait, I did 9, and I guess I did 7. Okay, so I guess I did an extra one for you before. That's okay. So I did 9 for you, so you got a little hint on that one. All right. Let's see if I did 11. So it says the statistic S is used for what estimated for? Oh, that's standard deviation. That's it. Okay. 13 I did. There's no, and there's just 15. Okay, the following graphs are sampling distributions in 2 different point estimators, X and Y, of the same population parameter. Okay? So which of the following statements is true? Well, if they're the center, it says X and Y. If they're the center here, right? This looks like this is a sampling distribution. Guys, remember what a sampling distribution is okay, we go out and I have, okay, each dot represents 100 people, and I have 50 dots. I went and asked 100 people, you know, this is where, let's say 30%, 40%, 50%. I went and asked 100 people, how many, do you like chocolate, right? And I got 30% said, yes, I like chocolate out of those 100. Someone else got 30%. Someone else got 40%. Someone got 50%. Someone got, and so forth and so on. So that's what that represents. And so that's what these are. These are sampling distributions. Well, if you notice, right smack in the middle is where the population parameter is. Remember, population parameter is what my true population is. And if they're the same, the mean, if you see, it is the mean. Look, this is the mean because if I split this in half, that's a balancing point there. Same thing here. Look, it's a nice balancing point also. So this is the center of this one, and so therefore they are not biased. If the mean of the population is equal to the mean, then they are not biased. All right, next one, part B, number 1. Okay, so this one's what's the mean of the sampling distribution of the sample portion with people with blue eyes with a sample size 100. So we have N is 100, and I have P is equal to 0.17. So we're going to do 0.17. This is the formula. It's on your formula chart. 1 minus 0.17 over 100. Okay, and so that's my standard deviation. Sorry. It asks for the mean. The mean is just 0.17. Well, you know standard deviation too if you need standard deviation, but that's the mean. The mean, remember, is equal to the mean. Okay, so number 3 I did. So number 5. A manufacturer of computer monitors says that 4% of the monitors manufactured have a screen defect. So this is the population proportion of all manufacturers with a screen defect for the sampling distribution of the sample portion of size 100, N is 100, Which of the following is the best interpretation for 0.04? Okay, so make sure it's, if you look at this, this is not size 100. For each sample, that's a problem because that means every single sample has to be exactly what this is saying. For randomly selected screen monitor, it doesn't give me a size, so we know it's got to be A or B. For all samples of 100, these are the same. This says the standard deviation of all possible samples of monitors at the screen size of 0.04. No, this is my mean. My standard deviation would be this, 0.04, 0.96 over 100. But it's asking for the mean, so that's why I go with A. Okay, we did 7, 9. This is asking for which of the following statements is correct about the approximate normality of the sampling distribution of the difference in sample proportions of the residents that report regularly recycle. Well, we have 75% of the residents that report that they regularly recycle, and we have 90% in the other city that regularly recycle. Simple random samples of 75 residents are selected from each city. So we have N1 is equal to 75 and N2 is equal to 75. And we have which of the following statements is correct? Sorry, of the approximate normality. So we're going to see, let's try to see if it's normal. Because we're going to have to check our N1, P1. So let's check that to see. So we have 75 times 0.75. And for that, you get 75 times 0.75. Oops. You get 56.25, and that's greater than or equal to 10. And then you need 75 times 0.25. So we're checking to see if it's big enough, and we need NP greater than or equal to 10, and N1 minus P greater than or equal to 10, and we have to check all of them. So we have 75 times 0.25 is going to be 18.75, and that's greater than or equal to 10, so that one checks. Okay, now let's try the other one for 90%. 75 times 90%. 75 times 90%, and that's 67.5. That's greater than or equal to 10. And 75 times 1 minus 90%, which is 10%, and that's 7.5, and that is not greater than or equal to 10. So no, that one does not match. So it says the sampling distribution is not approximately normal because all the sample size for the first city is large enough, the sample size for the second is not large enough. That is correct. Okay, and 11 I did. And let's go to part C. The mean age of employees of a large company is 35.2. The standard deviation of 9.5. Random sample of 4 employees will be selected. The mean and standard deviation of sampling distribution of the sample mean of size 4. Okay, so the mean is going to be the same, 35.2, and the standard deviation is going to be 9.5 over square root of the size, which is 4, which that's what that is. Okay, number 5. Which of the following is best interpretation of the probability that the mean is greater than 25 is 10%? So we have to see how many sample size for 50. So this one is 50, good. This one doesn't say, this one doesn't say, this one says 50, this one says 50, so good. So then next we're looking for the probability that my mean is greater than 25. So we're going to see the next thing that I'm going to be looking for. I'm looking for the probability that the sample mean. Let's see this probability of the sample mean. Good. Probability of the total wait time. No, because I'm looking for the probability of sample mean of this is total wait time and this is sample mean because that's exactly what that is X bar is my sample. And this says greater than 25. This is 23. I don't know why that says 23. Well, because it uses 23, I guess, is what it's doing. But this is asking here for 25. So that's why that be. And then I think, yeah, and then that's why it would be E. Okay, number 9. 2 populations, 1 pennies and 1 quarter. A random sample of 25, N is equal to 25. was taken. The mean age of the sample was 32, random sample of 35, so N2 is 35. Mean age, X bar is equal to 32, and X bar 2 is equal to 19. Okay, for the sampling distribution, the difference in sample means have conditions for normality met. Okay, let's check our normality conditions. Remember, we have, is it random? And for normality, for large, remember, large we have, this is a sample mean, so is N greater than 30. And we have N1 is 25 and N2 is 35. So we have a violation there. So these say yes, these say no. Conditions for normality have not been met because neither the sample size, well, not NAT, because this is, it says the sample size for the pennies is not large enough, which is just the pennies, right? And no information about the distributions of population. So meaning, okay, so the pennies maybe are not large enough, but that doesn't mean that it's not a normal model. Like it can still be a normal model, but because it hasn't told us that it's a normal model, don't know what the distribution is, we say, oops, it's the sample size has to be bigger than 30. Only if it's bigger than or equal to 30, that guarantees normality. So since we don't know the sample size, we can't assume normality. We did 11, and that is it. All right, so what I want you to make sure you do is go back through your problems and make sure that you understand everything and you're able to go through all the different things. I'll make sure I have everything open for you so you can go ahead and continue on the ones you need to work on. All right, thank you.